Hi, this is Alex from devstories.eu, LangChain v1.0 Orchestration Framework, episode 20 of 20. Every time you want your agent to talk to a new database or API, you end up writing a custom wrapper. Your codebase fills up with brittle integrations that break whenever an external API changes. This limits how fast you can scale your applications. The solution to this integration bottleneck is the Model Context Protocol, or MCP. Think of MCP as USB-C for AI agents. It standardizes how tools and contexts are exposed to large language models. Before this protocol, if you wanted your agent to query a database and check a weather service, you had to write specific Python functions for both, define their input schemas manually, and bind them to your model. With MCP, the external service itself provides a standardized interface. Your agent simply plugs into it and instantly understands what tools are available, what arguments they require, and how to execute them. A common misunderstanding is that using a remote MCP server means your agent logic is moving over the network. Here is the key insight. Your agent remains completely local. The remote server does not run your agent or control its reasoning. It merely exposes a list of standardized JSON schemas representing the tools it supports. Your local agent reads those schemas, decides which tool to use based on the user prompt, and sends an execution request back to the server. The execution happens there, and the raw result is returned to your local agent. In LangChain, you manage these connections using the multi-server MCP client. This component acts as a central hub. It allows a single agent to connect to multiple different MCP servers simultaneously, gathering tools from all of them. The client handles the underlying communication using different transport layers. The two primary transports you will configure are standard input and output, referred to as STDI, and HTTP. Let us walk through a concrete scenario. You're building an agent that needs to perform complex calculations using a local Python script while also fetching live weather data from a remote service. Instead of writing custom tool wrappers for these tasks, you configure the multi-server MCP client to handle both. First, you define your local math server using the STDI transport. You configure the client with the command to run, such as your system Python executable, and the path to your math script. When the client initializes, it spins up this script as a local background process. The LangChain client and the script pass messages back and forth directly through standard input and standard output streams. Next, you define the weather server using the HTTP transport. For this, you just provide the endpoint URL of the remote weather service. This setup typically relies on server-sent events to maintain a persistent connection, allowing the agent to request actions and stream responses over the web. Once both transports are defined, you initialize the multi-server MCP client. The client immediately reaches out to the local math process via STDI and the remote weather URL via HTTP. It asks both servers to hand over their tool definitions. It collects the schemas, merges them into one continuous list, and provides them to your LangChain agent. From the perspective of the agent, it just sees a unified list of available tools. It is completely unaware that one tool executes in a local binary process and the other triggers an HTTP request to a server across the world. The shift towards standardized protocols means you can spend your time building better agent logic instead of maintaining endless API wrappers. Since this is the final episode of the series, I highly encourage you to read the official LangChain documentation and try setting up a local MCP server hands-on. If you have suggestions for topics you want to see in our next series, visit devstories.eu and drop us a message. The true power of an agent lies not in what it knows, but in what it can seamlessly connect to. That's all for this one. Thanks for listening and keep building.